Okay, so let us start today's discussion. Okay, so today we will start with joint characteristics function. First, we will discuss the basic theory part of basic joint characteristic function and joint moment generating functions. Okay, then we will solve some problems. Just very basic some theory we will discuss first. Okay, so let us discuss joint characteristic function. We consider two random variables, x and y. Okay, these are two random variables. Okay, x and y are two random variables. Then the characteristic function will be joint characteristics function of x, y. The joint characteristic function will be of x, y. We will define phi of x, y. We will write it in terms of omega 1 and omega 2. is expectation of e to the power j omega 1 x multiplied with e to the power j omega 2 y. Okay, so we can write it as expectation of e to the power j omega 1 x plus j omega 2 y. Okay, there are some properties of giant characteristic function, but we will discuss those in terms of problem solving. Okay, sorry. Okay, we'll solve some problem, and before that let us discuss in few lines the joint movement generating function. Okay, okay, joint movement generating function. Again, x and y are two random variables, so the joint movement generating function will be, we will denote it as v1 in terms of v1 and 2, which are two scalars. This is e to the power v1x multiplied with e to the power v2y is equal to expectation of v1x plus v2y. Okay, so let us try to solve some problems first. Okay, Okay, example 1. The joint characteristic function of two random variable x, y is given. The joint characteristic function of two random variables x and y is, it is given phi of xy and phi xy of omega 1 omega 2 is equal to exponential of minus 2 omega 1 square minus 8 omega 2 square. Okay, this is given. Question 1 of example 1. So that x and y are random variables. This is our first question. So mean are the first order moments, right? Okay, so let us start solving this question. How can we solve this? If we calculate the first order movement, and if we notice that it is 0, then it is 0 mean random variables. If not 0, then non-zero mean random variables, right? So given okay, so the joint movement of joint movement of n plus k order, or of order the joint movement, or rather movements of n plus k order can be written. How can we write? M of nk is equal to minus j to the power n plus k derivative of order n plus k, of which of phi xy omega 1 comma omega 2 with respect to delta omega 1 and delta omega 2 k. Okay, for omega 1 is equal to omega 2 is equal to 0. Okay, so this is the equation of joint movements. So if we calculate m10, what is m10? M10 is basically expectation of x. Okay, so what will be expectation of x? Please try it using this formula. So let us write minus j to the power 1 delta phi of xy omega 1 omega 2 n is 1, right? And k is 0, so it will be delta omega 1. Fine. So let us calculate the derivative. Again, the condition is same. Omega 1 is equal to omega 2 is equal to 0. Okay. So if we make the derivative, then what will come? Let us see. It is nothing but minus j delta value is given expectation of exponential of minus 2 omega square omega 1 square minus 8 omega 2 square derivative with respect to omega 1, right? And the condition is given omega 1 is equal to omega 2 is equal to 0. Fine. So this is what I need to calculate. So what will be the derivative? Derivative will be simple exponential of minus 2 omega 1 square minus 8 omega 2 square multiplied with minus 4 omega 1, and what is the condition? Condition is this one. Okay. And if we put omega 1 is equal to omega 2 is equal to 0, then we will get minus j exponential of minus 0 minus 4 multiplied with 0 is equal to 0, right? So can we say that x is 0 mean random variable? Yes, because expectation of x is 0. Now we will see whether the mean of y is 0 or not. Okay. In similar way, let us check. So we will calculate M01, which is expectation of y. Okay. So using the same equation, this equation, we can write that this is minus j to the power 1 derivative of phi xy of omega 1 omega 2 derivative with respect to delta omega 2, right? Again condition is same, omega 1 is equal to omega 2 is equal to 0. Minus j delta of exponential, what is the value? Value is minus 2 omega square minus 8 omega 2 square. Exponential of minus 2 omega 1 square minus 8 omega 2 square. Okay. Derivative with respect to omega 2. Condition is same, omega 1 is equal to omega 2 is equal to 0. Okay, let us keep it in bracket. So what will we get? We will get exponential of minus 2 omega 1 square minus 8 omega 2 square multiplied with minus 16 omega 2, and condition is omega 1 is equal to omega 2 is equal to 0. So let us put the value. We will get minus j exponential of 0 multiplied with 16 into 0, which is 0. Okay, so we are getting that expectation of x is equal to expectation of y is equal to 0. So we are getting expectation of x is equal to expectation of y is equal to 0. Hence we can say that x and y are zero mean random variables. Okay, this was what we need to show. Okay, hope you understand. Now we will come to the second part of this question. What is the part 2 of the question? Are x and y correlated? This is our question. So how can we solve this? If x and y are correlated, then expectation of xy will not be 0, and if it is uncorrelated, then expectation of xy will be 0. Okay, so we will calculate the correlation, that is rxy, right? In previous session we have discussed this symbol, expectation of xy, and we can write it m11. Now take 2-3 minutes and you try to write down the equation of m11, or the expression of m11. Then match with the answer. Okay, first you try, take 2-3 minutes. Have you tried? Okay, let us write. M11 we will use this expression. So this is minus j square, right? Delta xy we can write like this. Phi xy omega 1 omega 2, and derivative with respect to what? Delta omega 1 delta omega 2. And what is the value of omega 1 omega 2? This is again omega 1 is equal to omega 2 is equal to 0. Okay, so let us try to solve this. This is minus j square. We can simply write del square also. This is exponential of minus 2 omega 1 square minus 8 omega 2 square. Delta omega 1 delta omega 2. Okay, so this is minus j square exponential of minus 2 omega 1 square minus 8 omega 2 square multiplied with okay, let us do this step by step. First, we derivative with respect to y. So what will we get? Minus 16 omega 2 this is delta omega 1 this is minus j square. Now we'll derivative with respect to omega 1. So this will be as it is minus 16 omega 2 exponential of minus 2 omega 1 square minus 8 omega 2 square multiplied with minus 4 omega 1. Okay, so this is 0 only, right? Okay, this was 2. Okay, so we can say x y are uncorrelated. Okay, so this is our answer, right? So everyone, I hope it is understandable. If there is any query, you can write in the chat box. Now we will try to solve another question. Example 2. Okay. Joint density of xy is given. Joint densities if of xy is equal to xy plus 15 for 0 less than x less than 1 and 0 less than y less than 1. This is the condition and this is elsewhere. Okay. Question is find the joint moments. What was the indication? MNK for NK is equal to 0, 1, 2 and so on. Okay. Okay, so joint moment, how can we calculate? Let us try to calculate. MNK is equal to basically expectation of x to the power n y to the power k. Okay, and we can write it as double integration minus infinity to plus infinity x to the power n, y to the power k, f of xy dx dy. Okay, hope it is understandable. Okay, so you can write it as minus infinity to plus infinity. It is double integration, right? X to the power n, y to the power k, f of xy is given. Okay, what is the value? This is 0 to 1, y 0 to 1, this value, otherwise 0. So we can change the limit now. 0 to 1, and it is x into y plus 15 dx dy. Okay, okay, so let us calculate double integration 0 to 1 x to the power n plus 1 y to the power k y plus 15 dx dy. Okay, this is again 0 to 1. We can write it as x to the power n plus 1 into y k plus 1 plus 15y dx dy. So we can write it 0 to 1 x to the power n plus 1 this is y to the power k plus 2 divided by k plus 2 plus 15 y squared divided by 2 y is equal to 0 to 1 dx, right? Is it fine till now? Okay. Now if we derivative the rest of the part, then we will get x to the power n plus 2 divided by n plus 2. Limit is simply x is equal to 0 to 1, and rest of the part is same. This is yk plus 2 divided by k plus 2 plus 15 multiplied with y square by 2 y is equal to 0 to 1. Okay. So this is 1 upon n plus 2 minus 0, and this is 1 upon k plus 2 plus 15 by 2, right? Minus 0. Okay, I think there was little mistake. Yes, but it was y. It was y to the power k. So we will get y to the power k plus 1 divided by k plus 1. Similarly, this is also k plus 1. This is k plus 1. This is 15 upon k plus 1. So this is the answer. So what we are getting so mnk is equal to Can we simplify it little more? Yes, it is 1 upon n plus 2 multiplied with k plus 1 k plus 2 in numerator it will be 16k plus 31. Right, so we can write it as 16k plus 31 divided by n plus 2 into k plus 1 into k plus 2. Okay, for n comma k is equal to 0 1 2 and so on. Okay, the students, please take some time, 2-3 minutes, and try to understand what we have discussed till now. If there is any query, please write in the chat box. Okay, so let us discuss next question. If there is any query, is there any query? No. Okay, then we are going to example 3. Okay, example 3 is x and y are independent random variables. Okay, and it is given moments m10 is equal to 2, m20 is equal to what is the value of m20? 20 is 14, and m11 is minus 6. Okay, and we need to calculate mu22. Fine, mu22. What is mu22? It is the central movement, right? Okay, m10 is given, m20 is given, m11 is given, and also given is m02. M02 is 12. Okay, okay, so let us try to calculate. Mu22 is the central movement. Mu22 is expectation of x minus xz squared multiplied with y minus y hat squared.
तो अपने टॉपिक का ही है ना, सब्जेक्ट का टॉपिक।
Okay,
रिपोर्ट भी देना है यार।
as these are independent x and y, so we can write it as
रिपोर्ट भी देना है। रिपोर्ट में क्या टॉपिक वाले में रिजल्ट कर रहा है।
expectation of x square minus expectation of
इसको क्या डॉक्टर बता
whole square. Multiplied with expectation of y square
इसमें खुलेगा
minus expectation of y whole square, right? Okay. Okay. So we can write it as this is nothing but the mu m. This is second moment m 20. This is first moment square m10 square multiplied with m02 minus m01 square, right? Okay. Now we need to calculate, put the values, but check whether we have all the values or not.
20 को बोला ना 80 बच्चा 20 into 4 20
So if we check, we can see that we don't have one value. What is that? M20 and 02 we have 20 and 02 we have 10 we have 10, but 01 we don't have. So we'll use one property. As x and y are independent random variables, so can we say expectation of xy is equal to expectation of x into expectation of y? Yes. So as x and y are independent
अरे ये लगता है आउटलुक आउटलुक इसका नहीं है माइक्रोसॉफ्ट माइक्रोसॉफ्ट आउटलुक
X and Y are independent random variables.
Google, Google, yeah. और मेरे और माइक्रोसॉफ्ट एक्सेल
Independent random variables, right? So M11 is equal to M10 multiplied with M01. Okay, so we can write which value we don't have. M01 we don't have, so M01 is equal to M11 divided by M10, which is, what is the value of M11? M11 is given -6 and M10 is 2, right? So we are getting it -3, right? So mu22 is, we have M20 minus M10 square multiplied with M02 minus M01 square. What is the value of M20? 20 is given 14 minus M10 square. M10 square means 2 square. M02 is 12 minus M01 square. 01 we have calculated, minus 3 square. So this is 14 minus 4 multiplied with 12 minus 9, which is 10 multiplied with 3 is equal to 30. Okay, so we got M22 is equal to 30. Okay, hope it is understandable, students. Please take 2-3 minutes and try to understand. Then we will proceed further. Please try to understand how we have calculated mu m01 and then we have calculated mu22. Hope it is understandable. Any queries till now? If not, then we will proceed further. Next is example 4. Okay, what is example 4? The density function of two random variables x and y is given. It is given f of xy is equal to 2 upon 43 x plus okay, and it is 0. For which value this is? This one 0 less than x less than 2 and y is 0 less than y less than 3 and it is 0 elsewhere. first part of this question is find first and second order moments. First and second order moment. Okay. So how can we find? First we will find the joint moment. Okay. So first we will calculate the joint moment. Joint moment of n plus k ordered. Nk is equal to, we can write minus infinity to plus infinity, double integral, right? X to the power n, y to the power k, f of xy dx dy. Okay, so to replace the value f of xy using this, we can change the simply limit, right? This is x is equal to 0 to 2, y is equal to 0 to 3. X to the power n, y to the power k, 2 upon 43, x plus 0.5y whole square, right? This is dx dy. So let us solve this. We can write it as limit is x is equal to 0 to 2, y is equal to 0 to 3. Okay. X to the power n, y to the power k. This is 2 upon 43. Can we write it as x square plus 2x into y by 2? That means xy plus y square by 4. Dx dy, right? Can we write this? Yes, we can, right? Okay. So two upon 43. This is, so what will be? X is equal to 0 to 2. So is there any query, students, till now? Any queries till now? So this is y is equal to 0 to 3, right? So we can write it as x to the power n plus 2 y to the power k plus x to the power n plus 1 y to the power k plus 1 plus 1 upon 4 y to the power another x to the power n y to the power k plus 2 x to the power n y to the power k plus 2, right? This whole will be in bracket into dx dy. Fine. Now let us integrate this. So this is 2 upon 43 x is equal to 0 to 2, and with respect to y will make the derivative. It will be x to the power n plus 2 multiplied with y to the power k plus 1 upon k plus 1 plus x to the power n plus 1 multiplied with y to the power k plus 2 upon k plus 2 plus 1 upon 4 x to the power n y upon k plus 3 divided by k plus 3. This is y equal to 0 to 3 dx. Fine. So let us put the value and then we will integrate with respect to x. This is 2 upon 43 x is equal to 0 to 2. This is x to the power n plus 2 into 3 to the power k plus 1 upon k plus 1 plus x to the power n plus 1 multiplied with 3 to the power k plus 2 upon k plus 2 plus 1 upon 4 x to the power n 3 to the power k plus 3 divided by k plus 3 dx. Fine. Now integrate with respect to x. This is 2 upon 53 into, we can write it, x to the power n plus 3 upon n plus 3 multiplied with 3 to the power k plus 1 upon k plus 1 plus x to the power n plus 1, sorry, n plus 2 upon n plus 2 multiplied with 3 to the power k plus 2 upon k plus 2 plus 1 upon 4 multiplied with x to the power n plus 1 upon n plus 1 multiplied with 3 to the power k plus 3 upon k plus 3, and x is equal to 0 to 2. Okay, so now let us put the value of x. We will get 2 upon 43. This is 2 to the power n plus 3 3 to the power k plus 1 divided by n plus 3 multiplied with k plus 1 plus 2 to the power n plus 2 3 to the power k plus 2 divided by n plus 2 multiplied with k plus 2 plus 2 to the power n plus 1 3 to the power k plus 3 divided by 4 multiplied with n plus 1 multiplied with k plus 3. Okay, so this is the joint moment. Now the question is, first movements we have to find and second movement. So what are the first movements? First movements are M10, right? M10. M10 means n is equal to 1 and k is equal to 0. So we can write it as 2 upon 43 2 to the power 4 and 3 to the power 1. Okay, divided by 4 cross 1, that is nothing but 4. Okay, plus n is equal to 1, so it will be 2 to the power 3 and 3 to the power 2 divided by 3 cross 2 plus 2 square 3 cube divided by 4 cross 2 cross 3. Okay, so what we are getting, this is 2 upon 43. So from here we will get 12. From here we will get 4 plus 3 12. From here we will get 3 cube, no, 3 square, 9 upon 2. Okay, so it is 2 upon 43 cross 2, 24 plus 48 plus 9, right? 57. Basically it will be 57 upon 43. Okay, what is this? Is M10 means expectation of x. What is expectation of 1 y? It is M01. M01 is 2 upon 43. 01 means n is equal to 0, k is equal to 1. So it is 2 to the power 3, 3 to the power 2 divided by 3 cross 2. Okay, because n is equal to 0, k is equal to 1, plus 2 square 3 cube divided by 2 cross 3. plus 2 into 3 to the power 4 is equal to 2 to the power 1 divided by 4 cross 1 cross 4. Okay, m0. So what is the answer? It is 2 upon 43 divided by 12. Okay, this is 12 plus 18 plus 81 upon 8. This is 2 upon 43 multiplied with denominator is 8 which is 30 cross 8, right? Plus 81 321 321 upon 43 cross 4 172. Fine, this is the expectation of y. Now we need to calculate the second moment, that is m20. Second moment, sir, first one is m20. Okay, let us write it here for our better understanding. Just for simplicity. Okay, provided by n is equal to 2, k is equal to 0, right? So let us write it is 2 upon 43, n is equal to 2 means 2 to the power 5, 3 to the power 1 upon 5 cross 1, or rather it is like this. Okay, 2 to the power 4, 3 to the power 2 upon 4 cross 2 plus 2 to the power 3 sorry 3 to the power 3 divided by 4 cross 3 cross 3. This is 2 upon 43 . This one we can write as 96 by 5 plus 2 to the power 4 multiplied with 9, 140. Okay, we can cut it answer, right? 8 means we get 9 cross 2, 18 plus, and here we will get 2 square will be cut out, so 2 cross 3, 6. This is nothing but 2 upon 43 multiplied with, in denominator it is 5, numerator 18 plus 6, 120 plus 96, 216, right? Simply it is 432 upon 215, near about 2. Okay, so similarly we can calculate we can find M02 and M11. Okay, so let us conclude today's discussion here.